Hello, welcome everyone. We can go ahead and get started. So welcome again. My name is Sierra and I am the Admissions and Program Services Manager at the Data Incubator. We are a fellowship, scholarship, and placement company. We have promised you an excellent info session that will be led by one of our instructors, Michael Cullen. I've linked a notebook in the chat that Michael will be using during his demonstration, so please make sure you have access to those notebooks and can follow along during the discussion. To start things off, I would like to give you a quick overview of our program and everything that we offer. Then Michael will jump in for our live demonstration, and we will leave some time for questions at the end. So please place all questions in the Q&A section, and we will answer them at the end of the presentation. As a reminder, our session is an hour long today, so if we don't get to all of your questions, please email us at admissions@thedataincubator.com, and we'll be happy to help you. So let's see if I can progress these slides. Okay, so the Data Incubator focuses on training people to become data scientists. Why is that important? It is really because data scientists have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a ton of different industries, from tech to finance to retail to healthcare and many more. Every company has data and wants to use that data to drive value for them. So what makes the Data Incubator different? There are a lot of other data science programs out there. So what do we do at the Data Incubator that's a bit different? Well, what we found is when you look at training, there are really two different types. One is fast-paced and efficient. Two is slower and focuses on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. On-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You'll walk out of our program knowing a lot about data science and real-world business applications, and with a deeper understanding as you'd get from university. All of our instructors are PhD and master's holders and have completed this program themselves and know how to provide that in-depth training that you're looking for. So a little bit more about our fellowship program. It's not your average program. It is intense. That is a fast-paced schedule I was speaking to earlier. It is 9 to 5, Monday through Friday for 8 full weeks. It's thorough, so each week focuses on a different data science tool or approach. In addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment, and each week you'll be working on a mini project that focuses on the data science tools that you're studying. Some of the topics we cover are TensorFlow, machine learning, Spark, and data visualization. Additionally, our program is very collaborative. We want students not only to work with their colleagues and instructors, but also to work on presenting to companies. Part of our program is working on a capstone project that you'll have the opportunity to present to our hiring partner network. You'll get feedback on how to present, how to create a capstone with a clear business objective, and a great portfolio piece to add when interviewing with companies. Our program is forward-thinking. We have career coaches that will help you with the career aspect of becoming a data science. Not only learning how to become a data science, but getting a job in the field. That involves work with your resume, cover letter, interview skills, and negotiation. To help connect our students with our hiring partners, we host virtual networking events as well. So we do partner panels where companies will come in and talk about what it looks like to work at a company and discuss problems that they are currently trying to solve. We also host Capstone Showcases, where students have the opportunity to present their projects directly to hiring partners. So we admit two types of students into our program. Fellows are offered tuition-free scholarships. We offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our program and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network and may maintain their current employment. Scholars still have access to the same curriculum, resources, and tools as our fellow students. So all of our students will have the same access and resources. The only difference will be that scholarship amount for our fellows versus our scholars. So that is just a little bit about our program. I will now pass off to Michael to lead you through our live data science demo, and then I will come back on the end to help answer any questions.
All right, thanks so much, and hello, welcome everybody. My name is Michael Cullen. As Sarah said, I'm one of the instructors here at the Data Incubator. I'm based out of New York. I'm going to put these notebooks just in the chat one more time. I guess one rather to a My Binder link, one to the GitHub repository. Then I'm going to go ahead and start sharing my screen. Chrome. Looks like this is sharing as I hoped it to be. Okay. So if you follow those notebooks, you'll see the following things. First, you will see this link to mybinder.org. And this will say we can enter a GitHub repository. Go ahead and click Launch here. This is going to basically just launch a little interactive Jupyter Notebook server that you can run directly from your browser. For those who may not have used these before, talk a little bit about Jupyter Notebook. So this is a piece of software, as well as, I suppose, a way of rendering a particular file format that lets us sort of mix nice, rich text and markdown, including things like pictures, images, and actually even little web browser windows, really all sorts of different things, alongside interactive and modular blocks of code, which may be in Python, maybe in other languages as well. So here we're looking at a Jupyter Notebook right now. I'm going to zoom in a little bit, so it's probably easier to read on the screencast. But you'll notice, we have some of these cells or blocks here. They're going to be called cells. This is actual Python code that I can run. To do that, we can click Run up here. I tend towards keyboard shortcuts, so I would hold Shift and press Enter, and that code will run. So this is the format we'll be working out of today. This is a tool that I use pretty much every day, partially for lectures and demos like this one, but also in my exploratory analyses and even preparing interactive reports to give to other people. And so today we'll be looking at sort of how Jupyter Notebooks might be used in exploratory analysis as we solve a particular problem. I guess I'll also note really quickly, so that other link that I shared will take you to this GitHub repository. From here, you can download the code yourself, either by cloning or forking from this repository or just getting a zip file, and you can run this on your own machine. I have a little bit of information on getting it all running in your own machine, but it shouldn't be too hard otherwise if there are any gaps to fill in. Okay, so we'll make sure we're running all of these cells as we go down. This one is just going to download some data that we'll be working with. And what is this data set? Well, let's check out this link. This is available on the UCI, University of California, Irvine Machine Learning Repository. A fantastic resource for free, open data sets for machine learning research, statistics, data visualization, whatever you want to do. There's a really broad range of pretty decently large data sets that you can play around with in here, all in one convenient place. So the one that we're working with is the Calit2 Building People Counts data set. And this is going to look at two data streams, inflow and outflow of a particular building over 15 weeks, 48 time slices per day. So every half hour, how many people entered the building and how many people left. The original purpose of this data set, can we predict if there is an event going on, or perhaps if there is about to be an event going on, things like that. So we have a couple different data sources here. I guess I could take us through those right here. We'll be sticking just with the Calit2 data and Calit2 events. Dodgers data and events are going to be just a little bit larger. Someone asked if we can send a link. Yeah, so that should be in the chat. I don't know if maybe WebEx, I don't know if perhaps WebEx doesn't show you the previous chat messages if maybe you got here a little bit late. But I'll just post them again really quickly. It'd be nice if there was a way of like pinning these things somewhere. That's for the GitHub. This is for the binder. All right. So, interesting. Okay. So we have our data itself. Let's talk about this format. We have some events that show from this date at this time till this time. We had some kind of event going on. But let's dive a little bit more into this format. So in that first one, each row consists of 4 things. There's a flow ID, where, thinking of the most probably intuitive and descriptive values here, 7 means outflow. So this is the number of people who left. 9 means inflow, the number of people who entered. Really remarkable choice of numbers there, but that's none of my business. We have the date and the time for that particular slice, and the count. So this many inflow, once again, and this many outflow. And then in the events file, we have a date. Again, we have the beginning event time, ending event time, 24-hour clock, and the name of the event. Now, for us, that's just being shown as 10, 20, 30. So essentially, we have 3 different types of events, to the extent that that's helpful. So we won't get all the way towards building a predictive model, but rather we will look at some of the powerful things that pandas can do. Maybe I'll talk a little bit about pandas. For working with temporal data, talk about some feature engineering, and the way that in exploratory analysis here, we would start trying to find, ways of manipulating or getting like relevant data out of this raw sort of, chunk of time data, I suppose. So again, this is what our data is going to look like. We're loading this into Pandas. If you are not familiar, Pandas is sort of the go-to library for working with tabular, table data in Python. It's very widely used. I highly recommend it. It's very fast and efficient because it's built on top of NumPy. It's rather intuitive, and it has really extensive capabilities. So we're working with Panda, loading in those CSV files. And I've just got a function here that's going to load and generally prepare our data a little bit. So we're turning our date and time actually into usable timestamp objects. And we are just turning flow from 7 and 9 into the actual in and out labels so that it actually makes sense what we're looking at. So at this point, here is the data after a little bit of pre-processing. Again, we have a timestamp. We have flow, date, time, and count. So this would say, I guess right here, July 24th, 2005, in between midnight and 12:30 in the morning, one person left the building. Awfully late night. And again, we have, so these timestamps, this is not just text, right? This is not just the characters spelling out this time, but rather it is like an interactive and pretty powerful object where I could grab this timestamp and I could say things like, give me the day of week for that particular day. So we would see that we are starting off, I guess I can note that Pandas is going to encode day of week 0 to 6, where 0 is Monday. So this first day here is a Sunday. Muting myself by accident. A question come in the chat about not being able to open this on your computer. Yeah, so that is why I shared this binder link so that everyone can use it from the same sort of like an instantly working environment. To get this running on your own machine, you would be doing things like installing Python through the Anaconda distribution. I have a few notes on that in the GitHub repository. Launching Jupyter, getting the Conda environment. So to make it easy, we're just going to do it through binder. That way we can all get it interactively. Okay. So again, we can do things like get the day of week. We can extract other sort of temporal values like the hour, certainly the month, and so forth. So this is going to be very valuable for us as we start manipulating this time series data. Currently, we have sort of this long format where we have out and inflow in the same column. Perhaps we don't want that. Perhaps we want to do something a little bit more like pivoting. And I have a little function here. I won't go through how all of this works exactly, but this is just doing a little bit more pre-processing where I'm saying, okay, give me outflow and inflow. Maybe let's consider the net flow for that particular chunk. So how many people entered minus how many people left. And then I've also just set for convenience, I've set a column for month and for day. Now from here, I might start looking at just some basic visualization. I haven't started matching this to the events data quite yet. We're on the way there, certainly, looking at what does a day with an event or what does, the time around one of these events look like in this building. But before we do that, let's see what we can do just to understand what this data is saying. So maybe rather than just looking at these individual chunks, I might want the cumulative flow throughout the day, right? I might want to see how many people enter from the start to the end of the day, how many people leave, and then maybe what does that net flow look like at each time check. And so that's exactly what we're going to do right here. So now, in addition, once again, to those individual chunks of time, I've also got cumulative. And if I wanted to now, I could pass in perhaps a particular day, and I could say, all right, give me just a plot of the net cumulative flow. So here's Halloween 2005. I could certainly turn this into something like July 15th, maybe. I actually don't think we have it that day. Fair enough. We'll do something like August 1st or 2nd. And we can see what that cumulative flow looks like. I also want to note once again, we're working with these date time kind of objects, not just strings, right? This isn't just characters. So interestingly enough, I could do something like September 21st, 2005, and that actually would work as well. So one of the conveniences that Panda affords us is that it's pretty intelligent as it pertains to, parsing out these ways of describing a date into something that actually will use. This also means that we said a particular day, and we were actually given all of the rows for that day, all of those half-hour chunks. Something we might try, and hopefully Pandas doesn't get mad at me here, but we could even look at the entire month rather easily. And if we think about these as days of the week, right, unsurprisingly, we see that there's probably, some periodic dips where not a lot of people are really coming and going. And we might think to ourselves, those are probably the weekends. People have a life. They're not going to be at the university all weekend, all the time. So again, just kind of previewing some of the nice time series and temporal things Pandas affords us, how easy it relates to plotting. Another key technique in working with time series is we might want to upsample or downsample a particular signal over time. Pandas makes this rather easy for us using this resampling thing, where I can say, okay, give me, I have half hours. Maybe I'd like to add up and actually just get a row for every hour. You can see what this would look like. Now we have something like this. Again, that's every hour. And using something like this, maybe I can say, all right, what does the average day look like just in my data? If I think about that, maybe just like the inflow over the course of the day, when people are coming in, what's that look like on average? So I have sort of an average day, and I have a confidence region that I've built around this. So now I'm starting to get a picture of what I would expect a day to look like, right? So that's not too bad. Sorry about that. Of course, maybe we're not really seeing the whole picture here because we have taken an average day over every single day we have. And is that really appropriate? I mean, we saw in this plot above that weekends certainly are very different from the weekdays. Someone asked what this confidence interval range was. So this is just given by a single standard deviation in either direction. So it's not like really not what we think of for like a testing confidence interval. It's just really it's more of, I guess, the a margin of error, perhaps. All right, so let's, again, we saw before that we could extract the day of the week. We saw that, yeah, I guess that would be given to us by things like the date. So maybe as we go forward, we might just look at those days where we have a weekday. So we're saying, all right, I only want the rows where it's a weekday, essentially, because 5 and 6 would mean Saturday and Sunday. So this would get me out of all of those weekends. And in fact, I might take something like this. And maybe I might move this. Is this going to get me hourly? This should be happening on EDF. This will work. Kind of doing this a little bit piecemeal here, which is not always the best thing to do, but I think it's good to work interactively. So now we might see something that's more like the average weekday. And for what it's worth, our margin of error has shrunk pretty considerably compared to when we started, because those weekends were so different. So that's something we'll keep in mind, as we start trying to put together values that'll be useful for detecting events, trying to, restrict or build our features around meaningful distinctions in our data, like at the sort of real world level, right? Well, let's then start playing around with this event data just a little bit. So I'm loading this in. I'm doing a fair amount of pre-processing, perhaps a little bit messy of me not to put this in a function, but this is exploratory analysis after all. And I'm going to say, let's just generally look at our events data frame. So here I say events.head. I've done this a few times so far. This will show us the first 5 rows of the data frame. And I've got a timestamp. I have start and end times and an event type. So we had before 10, 30, and 20. I've just turned that into 1, 2, and 3. So with our start time, maybe let's think about, okay, well, what time are these events starting? And maybe also worth looking at, how many events do we have? This is rows and columns, so there's going to be 30 events that we can base this on. Sorry about that. Really thought I had disabled that on my computer. Apologize. So we have these start times. Let's think about, okay, when are our events actually happening? So let's basically just pick up the 5 most common start times. It's like we have a lot of these starting at 9 o'clock, some of them starting right before lunch, some more morning ones, a little bit closer to the afternoon. And if we wanted to, we could actually see all of these. Not for nothing, this one starts pretty late. We also might be interested in knowing the length of these events. And it looks like many of these are going to be 3 hours and so forth. So we just were able to take 2 times and subtract 1 time from another. Again, one of the really nice things Pandas is doing for us. But okay, we've got a picture of our events. This doesn't tell us anything about people coming in and out, though, right? So why don't we take this and let's take our inflow, outflow data. Let's merge them together. So just a little bit of pre-processing before. And I guess I'll note also that where we're headed with this is, starting to think about predicting those events based on, some time window before things get started. So I guess I don't really need to have this here. I guess what I'll demonstrate is that I'm ultimately building this data frame that I'm just calling DF inflow window, where I have now timestamp, whether it's inflow or outflow. So I'm actually using my original long form data frame here. Maybe I could have used the pivoted one, but I have a date and time. And what we're looking at here is going to be a feature that I hope is going to help us predict whether or not there's an event that's about to start. Well, actually, this is the count for a particular chunk of time, particular half an hour. But here what we're looking at is how many people entered in the hour before just now. So if it's now 3:05, how many people entered between 2 and 3, essentially? Can I use that to predict if there's an event right now? Or actually, the way I've set this up, there's an event 30 minutes from now. So the 2 previous observations will tell us something about if an event is about to start. And I got that by joining first my events. Well, maybe not first. I joined my events onto this. So we have event type. Here we're saying not a number. So not an event in all of these. But for those 30 particular days, we would, of course, have an event. And so how does this happen? Well, a few things. And I guess it starts here. From my inflow data frame, I'm going to say, give me a rolling window. In other words, look at this chunk of time and the previous 2. Close equals left means actually don't look at this, just look at the previous 2, and add up the count for those. So that's how many people showed up an hour before now. Then I'm going to take that, I'm going to merge it back onto inflow, and just merging that onto events got us to here. So I know how many people showed up in the past hour, and when there are events, we would have actual values here. Okay? Well, my hope ultimately is that if there's an event, let's say half an hour from now, then in the last hour, probably more people would show up than we would usually expect. So let's just do a really, really basic approach to this. Let's say, take all of these missing event type values. Let's just call it 0 for no event. Let's group by the, well, actually, and this is, I'd like to start with something even more simple. Let's say with that data frame I had above, let's turn those missing values into zeros. And let's say group by the event type. Let's grab hour before. That's how many people showed up in the last hour. Let's look at the average. So this tells us, for each event type, how many people on average show up an hour before the event. And it would always be good to write these things correctly. And maybe things are looking pretty good for us, right? It looks like there's a pretty huge difference. Event type 1, about 10 more people on average. Event type 2, even more. Event type 3, even more still. But we need to be a little bit careful here, right? And this is because we looked here just at every single hour difference from this hour to the last hour, which means 0 here is sort of masking something that maybe we don't want. Event type 0 contains all of those times where there was no event, and that would include things like between 3 and 4 a.m., where we probably wouldn't expect that many people showing up in the building. So we might want to be a little bit more careful. And I might start heading towards something like this. All right, well, what about for this particular time of day and this particular event, how many people are showing up on average? And I can sort of put that together here to one that just contains where there are events. So now this starts looking like, all right, so for events, when we have type 1, looks like we have about 9 people on average versus no event. Actually, it's about 2.5. This is still not getting us towards statistical testing. It's just basic exploration, trying to figure out where there are signals that we can make use of. And it looks still like there's a pretty promising amount of information. However, we still probably haven't done things such as factoring out the weekends, or maybe even trying to do this according to the day of the week. Maybe we want to match each one of these events to every other Tuesday that happens. And this is certainly, where we would be headed. Rather than do that, though, I want to talk just a little bit about, and this got moved to another section. Let's just talk about how we can work with and visualize some of those other features. So we noted that we had those weekdays, and it's in. So for all of just the days with, like all of the, I guess, considering Monday through Friday days, this is telling us just a histogram of how many people entered in a particular day. So what does an average total inflow look like? What does that distribution look like? We also might do things like, actually this is going to be showing up later too. We also might be looking at the month instead. So now I might say, all right, I've got my DF pivot here that had month and day. Well, okay, what does average inflow, outflow, net flow look like per day, really per month? Is that saying what it's supposed to be saying? I think it is. Or I'm sorry, what does each chunk of the day look like on average per month? And again, this is only one part of the possible signal, right? We might want to do this by day of week. We might want to do this by month. We might even consider getting more information, perhaps by scraping from the school's website to see if we can get, when semesters were starting and stopping and things like that. Of course, that's kind of a whole other story. Now, as we start doing all of these things, we'll have a lot of different pieces floating around. And, we might be interested in capturing broad trends, just to, again, sort of see what's happening in our data as we start heading towards really, sort of robust, or I guess maybe I should say rigorous, predictive models. So I'd like to motivate kind of one more idea just in the realm of visualization, the idea of small multiples, and in particular looking at Sparklines. Sparklines are something that you actually may have seen fairly recently. This is essentially a type of line plot in which we have a whole bunch of different categories or levels sort of put in a table. It's like a lot of tiny subplots next to each other, or I guess above and below each other. But with a Sparkline, what we're really interested in is just what does the trend look like? So we're going to get rid of a lot of the actually axis labels and tick marks. We're not getting a really precise high grain data in a visualization like this, but just a picture, a snapshot of our data. So for instance, and I've just written a couple helper functions here. Let's look at what a day of the week looks like from the start of the day to the end of the day, just dealing with the inflow. So it would appear maybe that maybe it looks like we have pretty similar shape. Saturdays, maybe a little bit rockier, a little bit less reliable. Maybe Fridays, looks like maybe a few less people are coming in. But this is something that's just particularly useful if we want to just understand the general contours of a whole bunch of things at once. So let's keep in mind, if we wanted to put all of these on one plot, we would now have one of my personal pet peeves, which is 7 different lines on a single line plot. We have to remember what color is what, and so forth. So thinking of these as a table, thinking of this as a snapshot of our data in a Sparkline like this, certainly very useful. And just to demonstrate the flexibility here, we're doing something like this. What is the average day by each month? Maybe does that tell us, maybe the scheduling of classes might be different around each month. Again, just kind of demoing different ways that we can, try to capture and visualize, express a lot of time-oriented temporal data at once. Next steps from here, would be taking all of these separate pieces we put together, bringing them sort of probably into one data structure, trying to put that into, some predictive models, but that would certainly be a lot more involved than this sort of brief exploratory analysis here. All right, so that is going to wrap things up for me. I know that Sierra has a little bit more to present, and then we'll have some time for questions after that. So thanks, everybody, and let's see if I can figure out how to switch this back to Sierra.
Okay, I think I got my screen back up. Thanks, Michael. Okay, moving on. So a big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts, but also getting placed in the field. So as you'll see from here, 97% of our students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers. We're really proud of those and have worked really hard for them. That's part of the challenge, not only learning the content, but being able to transition into a data science role. That's really where our program stands out because we help you to do both. So where are our graduates now? Where are they working? What are they doing? Our graduates are working in 55 different industries. Some of the most common industries we see are computer science, internet, IT, financial services, and biotech. Some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are some of the roles we've placed in the past. So here is a short list of some of our hiring partners. You are also able to email us at admissions@thedataincubator.com for more detailed list of our hiring partners as well. So many have asked if we offer finance options, if we offer assistance, and the answer is yes, we do. Especially during times like these, it's hard because people may have extra time to participate in our program, but limited cash flow. So we want to make sure that we help you with that. We've partnered with Leaf to provide an income sharing agreement. It's really great. You can participate in our program with just a deposit down, and you won't be required to make any payment until you've graduated from the program and are working and earning more than $40,000 annually. We also provide loans through Climb Credit. These loans can also assist with covering housing and living expenses if you need help there. STILT also offers loans for international students. We know we have students who participate in our program but do not have U.S. Social Security numbers, and STILT can assist you with financing. So where are we right now? Well, we do 4 cohorts a year, and we are actually in the 3rd week, I believe, of our fall cohort. And our application is currently open for our winter 2021 cohort. So our winter cohort will run from January 11th through March 5th, 2021. As I mentioned earlier, the cohort is 8 weeks long. Some specifics about the application. We ask that you submit your application by November 6, 2020. You'll have 72 hours to complete the challenge from the time you open it. The challenge deadline is November 9th. So you cannot complete the challenge unless you submit the application. Just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We are unable to reopen the application or challenge after that deadline. So if you are interested in applying into our program, which I really hope that you are, you can go to the dataincubator.com/apply to submit your application. I will also drop the link to our email address and the website where you can apply in the chat. And again, if you have any questions about your specific situation, this presentation, or going through our application process, please reach out to us again at that email, admissions@dataincubator.com, and we'd be happy to answer your questions. So at this point, I'll open it up for the Q&A and see if there are any questions that haven't been answered yet during the discussion. So I do see a question in there, and I'm unsure if, Michael, you've already answered this, but it says, is the accumulation over a day? I'm guessing this is from your presentation earlier.
Yes. In those, I guess it depends on the cell you're talking about, but we did a few things. We, for instance, added together 2 half-an-hour chunks to make hourly chunks. We did accumulate over a day for like the total number of people who entered in a single day. So it might have been talking about that one. But Pandas is certainly very flexible for, various degrees of resampling or aggregating.
So another question in here, hello, do you have a list of demos you're planning to do? I'm specifically interested in deploying to Heroku. So we don't have a list of demos that we've distributed to our students or applicants yet, but we will be in communication with you as we plan to host them. We do have an info session coming up, I believe it's November 3rd. So that gives some insight into our program and our coding challenge, and we will send out emails similar to what we did with this WebEx just to notify you when to attend. Another question I see.
That being said, I typically do a lot of these demos, and working with Flask and Heroku has been on my mind as a apt topic recently, so perhaps that will show up in one soon.
Another question says, hello, Sierra, I'm interested in your program. May I ask, when is the early application deadline for summer? So we have not finalized our summer 2021 dates yet. Our summer cohort this year ran in May, so typically the application is open about 2 months before that for the early application. So just keep an eye out. Our website will update with those dates, and we will let you know when you're able to apply for early admissions. Question here, don't see the link to the binder. Is there a separate chat? I only see the Q&A panel. Oh, so they were able to get the link. So it is in the chat, and I see you're able to get that. Another question for you, Michael. It says, are you going to present anything about Git and GitHub?
I have done one of those before. I likely would do a GitHub one in the future. So yes, I have given one of these recently on working with for instance, GitHub Actions to bring in continuous integration into GitHub, and also a few things for making GitHub play a little bit more nicely with Jupyter Notebooks. So that's probably one of the demos that will be kind of cycling in from here on out.
Another question, is requirements.txt interchangeable with environment.yml for running a repo on Binder?
Okay, yeah, that's a great question. So Binder works well with tip or conda. Conda is the environment.yaml. Tip is going to be requirements.txt. I tend to stick with conda most of the time, actually, except for Heroku, works much better with tip. Because conda tends to be a little bit, I find it a little bit easier to work with, if nothing else, locally. And it also actually, I've found it to be faster deploying on Binder. Also, I'm going to, for the person who was asking about Git and GitHub, can't really get into detail with all of this stuff, but a repository I've shared for a previous demo. Can I? Oh, this is Q&A. Where's chat? I'll put it in chat. A repository I shared that's pretty, I think, decently documented what all these pieces do, about using GitHub with Jupyter Notebooks, and also using some GitHub Actions to sort of automatically test your code. So if you're interested, take a look at that. The recent live demo, which may be given again one of the upcoming ones.
Okay, next question. Let's see. So it says, I was not admitted last time I applied. What do I do specifically this time to be admitted? So I'd say one of the really great factors to pay attention to is when you're completing that coding challenge is doing your best as you are going through the submission. We also review the quality of your work, so not just the quantity, so you're not required to answer every question, so do your best on the questions that you are able to answer, and save often, and we will review your last saved submission. Also with your making sure that you show up for your interview portion of the application process as well as another important piece of it. So making sure that you upload a really strong resume, that you do your best on the coding challenge, and you present an interesting topic during your interview process is a really great way to stand out.
I will also share, let's see, and I don't know exactly where that question was. I'm just going to put it in the chat. We also review in the coding challenge how well factored and the style of your code. If you are writing code in Python for the coding challenge, probably a good idea because we write our answers in Python. I would recommend looking through this official style document, the PEP 8 document, for how to make code that is readable and effective. We certainly grade based on that.
Okay, so it says, does the pace of this lecture reflect the general pace that the program classes move at? And I'll let Michael answer this one.
I would say yes and no. The lectures are fast-paced, but probably not this fast-paced. Like in this demo, I was trying to, in like half an hour, show a lot of different things we can do with pandas, without really describing how all of them work. The lectures are, again, very fast because we cover lots of different techniques and tools in 8 weeks, but are certainly more in depth, and the notebooks are fully fleshed out as like references as well. This is kind of quick and dirty exploratory analysis.
Another question, does TDI have any hired partners in the Midwest? I believe we do, but we are able to give you a more extensive list than what was displayed in this presentation. If you email admissions@thedataincubator.com, let us know what specific areas you're looking for, and then we can send a list to you. Another question here is the winter session going to be online only? Yes, our winter session will be remaining online. We do hope to reopen our in-person classes when it is safe to do so, but for this upcoming cohort, it is planned to be all online. A question for you, Michael. It says, can you go over the definition of how you calculated the accumulated aggregations or aggregations?
Certainly, and this is in the code, but in getting, like, let's say, cumulated sum for each day, this would look something like, let's see, and I'll just write this in the chat as well. Let's say we have our data frame, and I wanted to group it by each day. Then I might do something like by each day, and then the cumulative sum. Or I might use resample, but again, all that is in the notebook, so I don't want to go too much into that. But this basically says if I do cumulative sum like this, this would mean for the first half hour of the day, I have just that one. And then at half hour 2, I have the first and second added together, and then the first 3 added together, and then the first 4 added together, and so forth. So that's what we're doing there.
Oh, let me see the next question in here. So it says, would it be okay with you for me to download this notebook? I believe the answer to that is yes, but I'll let Michael. Okay.
Yeah, it definitely is. We've got it on GitHub there with instructions for downloading and running locally. It's, yeah, totally, open source and public stuff on GitHub.
In terms of acceptance to the program, how much experience is needed to be accepted? Oh, sorry, this question is cutting off for me. Any specific languages? So we do require our students to have a previous knowledge and training in Python. You're not required to have, I believe, a mastery of that coding language, but I think some previous training, and I think Michael can maybe answer this question a little bit better than I can.
Yeah, totally. We're looking for meaningful experience definitely in computer science and like the statistical sciences, or at least and maybe that's not necessarily classical computer science so much as, computational statistics and data analysis. This might not necessarily be Python. We've certainly had people come in who really mostly have worked in R or MATLAB. I actually had a pretty strict foundation in R before moving to Python when I attended the fellowship. And, if you're very experienced with a similar language, we're not super worried about whether or not it's actually Python, but I would recommend starting to getting used to Python quickly, though, because we do work exclusively in it in the fellowship.
Okay, let me find the next question here. So it says, what should we expect in the coding challenge? So Michael, if you wouldn't mind, also pass that one off to you.
Yep. There are 2 components of the coding challenge. One is more pure computer science. The other is a data challenge. In the computer science one, you're typically asked to implement some kind of algorithm. And in the data challenge, we will provide you with a public data set. Oftentimes, this is like public sector, oftentimes like New York City, kind of open data. And you'll be given a number of challenge questions, to compute various statistics of or, transformed or aggregated values from this data set. This is something that I would recommend using pandas for. You can do it in R. I did it in R a long time ago, but we write it in pandas, and we like to read pandas, kind of Python code. Happy to read other stuff too, but pandas is a good way to go.
Another question here, is the challenge deadline for early application and fellowship consideration, or is that deadline for all winter cohort students? Great question. We actually just closed our early admissions application on October 9th. That coding challenge deadline was October 12th. So these dates that you are seeing below are for our regular application deadline. Our next question, what are you looking for in your applicant/students? So generally, our students that we see that are most successful in our program have a degree in a STEM-focused degree, and then also some previous knowledge of coding. I think we touched some points on the different coding aspects and coding languages utilized in the program, but generally those are the students that we see as most successful in our program in completing it. Let me see. So what is the selection criteria for the Scholar program? So again, we will review your application, we will review your resume, coding challenge, your project proposal, and then your interview, and all of those scores are compiled, and then we'll make our decision on Scholar or fellow placement. So does the fellowship program require the participants to already have a background or foundation in Python? I think we did touch on this point, but just as an additional information here, we do require our students to have some foundational knowledge of coding and Python. So if you have that previous experience, you'll be help you to be more successful in the program. So is the program lecture-oriented or project-oriented? Are we going to finish one big project in 8 weeks or 8 small projects with one finished each week? Do we design our own projects or we select from a list? So I would say the program is lecture and project-oriented. You will have lectures daily throughout the program. You also will have many projects each week, and on top of that, you will have your capstone project that you'll be refining over the entire 8-week period. So I don't believe you design your own projects. Your mini projects you will have be sent out to you by your instructors, and it will coincide with the data science tool that you're setting for that week.
Yes, although of course you do design your capstone projects, which you send a proposal of along with your application. I'm also going to, I have to hop off the call now. I have another engagement at 4. I just want to say thank you everybody for all of the great questions and discussion, and I hope you found this interesting and insightful.
Thanks, Michael. So I'll continue to answer questions for the next couple minutes. But if there are additional questions, we run out of time, again, that email that I put into the chat, you can send an email there, and then we will follow up with you. So does the fellowship offer training in an online format? Our cohorts are all currently running online, so we will be utilizing Zoom most often for your lectures. They will be live and instructor-led. So we do our best to translate our environment from our ground in-person classes to online. So it's really collaborative. You will still have that opportunity to network within your cohort with our hiring partners, but it will be in an online format. Another question here is, do we have to submit a project idea and preliminary outline of a project during the challenge? Yes, you do. A project proposal is a portion of the challenge. So you will present your project idea, what data set you plan to utilize, and then you'll also have an opportunity to do a revision at the end. So if you want to add some additional details or context to your challenge, you can do so as well. Are there hiring partners outside the U.S.? We do have some hiring partners outside of the U.S. I would say that most of our hiring partners are based within the U.S. So it will just be dependent on the time that you participate in our program if those hiring partners that are international have some availability or job postings at that time when you apply. So will you accept fellows and scholars for the winter session or only scholars? We'll be accepting both fellows and scholars for our winter 2021 cohort. So how long should we expect to hear back after we submit our application? So if you have submitted your application for early admissions, then we are reviewing your coding challenges and scores this week, and then we'll follow up, I believe, this Friday with an email letting you know what the next steps are, which would be our interview scheduling. With our regular admissions candidates, you'll have until November 9th to complete your challenge. We'll then review your scores that week. At the end of the week, we'll send you a link to schedule your interview. So I would say for early admissions, end of October, you should have an idea of your admissions into the program, and the same for our regular admissions, mid to end November, you'll have some information. So I see a question here, what industry domain spaces are covered in the program? Just because we are running out of time, I'll let you know, if you can please email us admissions at the Data Incubator. We can send you out a link to our curriculum, which will show the weekly topics that we will be covering, the prerequisites for each week, and some additional information. So I think that's a really helpful tool and be able to answer your question in a better way than I would be able to in the next minute. Let's see. So another question I see here, so is the fellowship program only for PhD candidates? It is not. We do accept students with master's and PhD degrees. We have also opened our cohort to students with bachelor's degrees that have 2 years of relevant work experience. Another question here, just to clarify, if I submitted coding challenge after October 9th, I will be considered for early deadline. So if you submitted your coding challenge by October 12th at 11:59 p.m. UTC, then you'll be considered as part of early admissions. If you submit it after October 12th, then you'll be considered regular admissions. So it looks like we are running out of time today. I'm so sorry I wasn't able to get to all of your questions. But again, thank you so much for showing up today. If you have any questions, please email us at admissions@thedataincubator.com. I really hope this session was informative. In the link in the chat, I've dropped a link to our website to complete your application, and also have uploaded our email address as well where you can reach us. Thanks so much, everyone, for your time today, and I hope you have a great rest of your day.